Number 4a from the free response section of 2021 says, let f be a continuous function defined by the closed interval of the graph of f. So graph of f is up here, so it is a function that is the derivative of g. So it says let g be the function defined by g of x equals the area under the curve from 0 to x of f of t. So first things first, it's important to recognize that this is a fundamental theorem of calculus, and that f prime of, or g prime of x is going to be equal to f of x. Okay, so that's an important concept. So question A says, on what open intervals is the graph of g concave up? And give reasons for your answer. Now, we want to look at we want to make a concavity and slope chart here to help us justify the answer. And when we talk about the concavity, we want the slope of g, or second derivative of g, which also means that it's the first derivative of f. So this is my f function, and we want the first derivative of that function. So when we take a look at the function, so I'm just going to start with the slope chart. We can do a slope chart here, and we can take a look at the slope chart based on the positivity and negativity of the graph. So it's positive all the way to here. There's my 0 point. So from x is -4 to x is 1, okay, we have a 0 slope here. We know that it is positive slope, so it's sloping up, goes like that. And then we also know that this section, so there's positive, and we know that this section here is negative, so it's going to be sloping down to there. Okay, so that's the slope chart. We really want the concavity chart though. So the concavity chart is going to be based on whether the graph is sloping up, or the change of the slope of the f graph represents the change of the change. So our f graph is sloping up in this section here. Okay, and then we have an undefined slope there. So from -4 to -2, we have an undefined slope here, but we know it's sloping up, so that means that the second derivative is positive, which means we have a concave up situation. In this section here, it's all sloping down. Okay, and again, we have an undefined slope here, and we have an undefined slope here. So although we have an undefined slope at 0, we know that it is negative slope through here, or concave down. Okay, we have a negative slope through to +2 here. So that means that the second derivative is negative, and we have, again, concave down here. And then an undefined slope at 2, and from 2 to 6, it is now sloping up. And so we know that the slope of the slope graph is positive, so we know that's concave up. So based on the concavity chart then, we can then state that in the open interval from this so we're going to say this concave up in the open interval from -4 to -2, and then from 2 to +6, okay, which are our endpoints. Okay, so +6 would be right there. Okay, so the concavity chart is going to give us the reason for the answer. We're going to justify the answer in that way. Part B says that let the function p of x be defined by g of x times f of x, and we want to find the derivative of p at x equals 3. Well, this problem is involving differentiating notation. So if I have my p of x function here, I'm just going to differentiate this with its notation. So P prime of x, it's a product, so I'm going to go G prime of x times f of x plus g of x times f prime of x. Okay, so we know also that we've defined that g is, the area under f is g, so the derivative of g must be f, so we can rewrite this in terms of f. So it's going to be f of x times f of x plus g of x times f prime of x. Okay, so if I want to find then the p prime at 3, I need to find f of 3, I need to find g of 3, and I need to find f prime at 3. Okay, so looking at the graph, going back up to the graph here, f of 3, the value of f at x equals 3 is going to be that point right there. I'm just going to zoom in. So that value is at negative 3. Okay, at x equals 3, f equals negative 3. So I'm just going to put that over here. So f of 3 is equal to negative 3. I want to know the f prime value at 3. The f prime value at 3 is going to be the slope through that point. So the slope through that point, if I take a look at that slope, it's got a slope of 1. So then I can define f prime at 3 is equal to positive 1. Lastly, I need to determine g of 3. Now g of 3 is going to be determined through the integral. So I need to find g of 3, and that's going to be the area under f from 0 to 3. So then if I take a look at this graph from 0 to 3, 0 to 3, well, we know that we have positive area here and we have negative area here. Those kind of cancel out. So we really are just looking for this area in here. Okay, so we're looking for that trapezoidal area, and that trapezoidal area is going to be 3.5. Okay, so then, negative 3.5 because it's below the x-axis. Okay, so we have positive 2 here, negative 2 here, and negative 3.5. So when we define g of 3 works out to be equal to, so I'm jumping around here, that's equal to 3.5, negative 3.5. So now I can just plug in all these values to determine the p prime value at 3. So this works out to be negative 3 times negative 3 plus the g value, we calculated to be negative 3.5. And then the f prime value at 3 is equal to negative 3. It's equal to 1, positive 1. So then we can calculate the rest of this. We end up with 9 minus 3.5, and that gives us a value of 5.5. So p prime at 3 is equal to 5.5. It involves differentiating the notation and also evaluating that g value as the area under the curve.